Hi, and welcome to the videos for section 1.6 for Math 126. This is the first of 4 videos. In section 1.6, we're going to be looking at modeling with equations sometimes you'll see it called applications of equations. It's all a fancy word for word problems. I know, everybody's favorite. But I'm going to show you a few tricks. We're going to look at very specific types of problems. Each of these videos is broken into specific types of problems and the methods that you can use to solve these problems. And hopefully, after watching these videos for this section, these types of problems become a little bit easier for you, or at least a little bit easier to set up. And then once you have them set up, you can follow through to solve them. So the first types of problem we're going to look at are investment problems and mixture problems. And I lump these two together because we can solve them the same way, which is what I call the table method. We can build ourselves a table, and the table essentially writes the equations for us, and there's not much that we have to do other than algebra at that point. So let's first look at investment problems. So we have the following example. Mary inherits $100,000 and invests it in 2 CDs, certificates of deposit, at her bank. One CD pays 4.5%, and the other pays 6%. If she earns $5,025 in interest in the first year, or in year 1, I'll call it in the first year, how much was invested at each rate? So, a few tricks with word problems. The first thing you want to do is read through the problem. I'll kind of point out some of the problems I see sort of as red flags, like don't do this if you can avoid it. So what I'll see a lot of people do is when they start trying to solve a word problem, as they're reading, they start trying to write the equations already. Step 1 should be read through the problem. Kind of try to get a sense of what's going on so that when you do start setting up equations, you can then ask yourself, does this make sense to what I thought it would be originally? So let's read through here. Mary inherits $100,000. She invests it in 2 CDs. One pays 4.5%, the other pays 6%. She's going to earn $5,025 in the first year. How much was invested at each rate? So think about what she's doing. She has this money. Maybe she put $20,000 in the 4.5% and $80,000 in the 6%. Would that have equaled $5,025 at the end of the year? That's what we're trying to figure out. What are those 2 amounts? Once we kind of have an idea what's going on, then we want to look to the last sentence usually. How much is invested at each rate? So then what you want to do is write yourself some variables. So let's say X is the amount at 4.5% and Y is the amount at 6%. We have 2 investments, so we need 2 variables. Now, as I said, with these kind of problems, with investment problems, with mixture problems, we can set up a table. And the table is the exact same for both types of problems. The only difference is the information we're putting into the table. So, I'm going to label, I'm making myself a table here, 2 vertical lines, 3 horizontal. This will give me all the boxes that I need for 2 investments here, or 2 solutions if I'm mixing 2 solutions. Then I want percentage, and here's the important thing, it's as a decimal. So we need to be able to convert percentages into decimals. And then for the investment problems, this last column is interest. And again, we'll see for a mixture problem, the last column changes the name, but the idea is still the same. Now the important thing here is when we have this table, and so if you have your cheat sheet and you want to kind of give yourself a blank table, this is what we have before we start. And once we start filling this in, some things are going to happen. We're going to multiply amount times percent gives us the value that goes into the interest column. And then vertically, so that's our horizontal movement. Vertically, it's plus. So this guy plus this one should equal what's at the bottom. So let's start filling this in for this problem. Our first investment, let's call it investment number 1, is how much we're investing in 4.5%. I don't know. That's one of the things I'm trying to figure out. So in this column, the percent, well, it's 4.5%. So as a decimal, that's 0.045. And so then the last column, I just multiply these two together. So this gives me 0.045x. Second row is my second investment, or if I'm mixing solutions, my second solution. So investment number 2, well, I called that y. As a percent, that's 6%, though, so that as a decimal is 0.06. And again, I'm just going to multiply across. So I get 0.06y. And then lastly, so this is the total row. So x, if I add down, these two should give me this. Well, what is this value? So I know investment 1 plus investment 2 was how much? It was 100,000. So if I have to be told some of this information, so adding down, I know that the amount I put in investment 1 plus the amount in investment 2 has to be 100,000. That was told to me in the problem. For my investment problems, this box, we just put a big X in it. It doesn't get anything put in there. And then lastly, this guy down here, well, what does this box tell me? It's the total interest. What was my total interest? 5,025. So that's what goes into that box. So the first 2 rows, my unknown investment amounts and their percent, I multiply across. And then this last row, the totals I can get from the problem. How much was invested? How much interest did I earn? And with these investment type problems, you're going to be given this kind of information. It's just a matter of filling in these boxes at that point. Now, why did I do this? We're trying to find out our answers, X and Y, right? The hardest part for everybody is to do what? Take a word problem and generate equations. Once they have the equations, people are pretty good at doing the algebra behind that. But it's like, how do I even get any equations to solve? Well, here's the beauty of this table. This column is equation 1. this column is equation 2. I have two variables, so I'm going to need two equations to be able to solve it. So equation 1 is what? X plus y is equal to 100,000, which makes sense, right? The total of my two investments is 100,000. The second equation, this is the one that would have been difficult to do if I was just trying to read this paragraph and figure out an equation. But now I have what? I have 0.045x plus 0.06y is equal to 5,025. So, now that we have these two equations, so I'm going to erase this. Hopefully you have all this written down at this point. Give myself some room to solve it here for you. So now that we have the two equations, we can solve this in one of two ways. What are those two ways to solve an equation in two variables? Well, substitution or elimination, right? So, can do either method. In this case, I'm going to do by elimination. So I'm going to multiply this whole row. So if I'm doing elimination, what I want to do, I want to pick one of my variables. I can multiply everything so that one of them will cancel out if I add down. So I'm going to multiply this whole thing by negative 0.6. I'm going to multiply each piece in this equation by negative 0.06. So what will that do? That'll cancel out my y values here and leave me with just x is equal to something, and then I can solve for x. So if I do that, my first equation becomes negative 0.06x minus 0.06y equals negative 6,000. So negative 0.06 times 100,000 is negative 6,000. Second equation, leave alone, so 0.045x plus 0.06y equals 5,025. So when I add down, I get negative 0.015x. The y values cancel each other out, and here I get negative 975. So now I have one equation with one variable. So I divide both sides by negative 0.015x. Sorry, not the x. Negative 0.015, negative 0.015. And when I do that, I get x is equal to 65,000. So that's what? And why did I define my variables? Well, x is the amount at 4.5%. So that means I invested 65,000 at 4.5%. I still have to figure out why, because I needed what? How much was invested at each amount. It didn't say how much was invested at 4.5%, or it didn't say how much was invested at 6%. It said how much was invested at each amount. So that would be what? I can use either equation. So I know that x, which is 65,000, if I use equation 1, 65,000 plus y has to be 100,000, which means y is equal to 35,000, which is the amount that was invested at 6%. And that's it. We really didn't have to do much thinking in terms of how do I write these equations. If I have this table and I just plug in the information, the equations pop out. Column 1, column 2. And then it's just some algebra after that, solved by substitution or elimination. So that's that example. If you need to follow through, need to pause it, follow some of the work, go ahead. I'm going to move on to the mixture problem, which is a similar type of problem. We're still going to use the table. So in this one, we have the following. So this again, this is a mixture problem. And it's, again, I use the table because what? An investment's sort of a mixture. It's a mixture of two amounts of money, right? So even though we call it investment problem, it's really ultimately a mixture problem. I'm mixing investment 1 and I'm mixing investment 2 to give me some interest at the end. Mixture problems will look like this. So a certain orange soda contains 5% orange juice, government regulations require at least 10% juice to be called natural. How much juice must be added to 900 gallons of orange soda to meet the regulation? So go ahead and hit pause if you need to catch up on the writing. I probably should have told you that last problem too. All these word problems we're doing in these videos for 1-6, once I get done writing, if you need to pause to catch up with the writing, then that's fine. It's a mixture problem. I'm going to build the table. Still the same idea. So 2 vertical lines, 3 horizontal lines, amount goes in the first column, percent goes in the second. And the only difference is now we're not talking about interest. It's a term we use called pure. So how much of it is pure solution? But the process is still the same. We're multiplying across equals the last column, adding down equals the last row. So, like I told you, read through what's kind of going on. Well, we have 900 gallons of soda. It's got 5% orange juice, but we want to be able to call it natural. So we need to add some juice to it in order to make the entire solution 10%. Well, we can't just say, all right, 10% of 900, so that's 90, so we need to have 9. Now, we can't do that because as we start adding orange juice, the total amount of soda and juice we have goes up, right? That's why we need to use this table. So in this case, our variable is what? Or how many variables do we have? We just have one, x, and that is what? That's the amount of juice that we're going to be adding. So row 1, we have, let's say, ingredient number 1. Row 2 is ingredient number 2, which in this case is the juice. Ingredient number 1 is what? It's the soda that we already have. And then again, the last column is always total, whatever, solution. So let's start filling this guy in. So how much soda do we have to start? Well, we have 900 gallons. And what percent of the 900 gallons is juice? Well, it's 5%. 5% is a decimal, is 0.05. So now multiplying across 900 times 0.05, if you put that on your calculator, you're going to end up with 45. Row 2. How much juice in our total solution do we have? Well, we don't know. That's what we're trying to figure out. So it's x. Now, This box here, what is this asking us? It's asking us what percent of the orange juice is orange juice. It's 100%, right? So if I have a bottle of water and I say what percent of this bottle of water is water, well 100% of it is water. Same idea here. If I have some amount of juice, X amount, and I want to know what amount of that juice is juice, well, it's 100%. 100% as a decimal is what? It's 1. So now multiply across, X times 1 is just X. And then lastly, I'm adding down. So 900 plus X, what goes in this box here? Well, this is going to be the total amount of soda and juice that I have when I'm done. So this value is 900 plus X. And we'll see in the homework, it might tell us we want to add 2 ingredients, maybe X and Y, so that at the end we end up with 1,000 gallons. So that would go here. But in this case, because we're told we have 900 gallons, and we're adding X gallons of juice, the total we end up with is 900 plus X. Again, we're just adding down. Now, this is the one box here. You remember in the investments, we just X'd it out. With the mixture, we're not going to add these down. This value is not 1.05. This value is our specified percentage that we want. So in the problem it tells us, well, in order for it to be called natural, it has to be 10%. So however much I end up with, this percent has to be 10% juice. So this amount, in the investment problem, we just X it out. It doesn't have a value in our table. In the mixture problem, it's the specified amount from the problem telling us we want it to be 10% juice or 18% acid or 30% water or whatever it might be, but it's going to tell us that. Once we have that, this process is the same, multiply across, so 0.1 times 900 plus X. So now the table's filled in. The difference between this and the investment is what? We only have one variable, so we only need one equation, which is going to be, I don't like using this red pen, it doesn't erase very well. I'll have to get the blue one. It's these guys, right? This one plus that equals this value. So that means my equation is 45 plus X is equal to 0.1 times 900 plus X. So one equation, one unknown. It's a matter of multiply everything out, simplify, move our terms around. Let's see what we get. So we have 45 plus X on the left. If I multiply 0.1 times 90, that gives, 0.1 times 900 gives me 90. And 0.1 times X is 0.1X. So if I move my x's to the left, I'm going to subtract 0.1 from both sides. So I get 45 plus, 0.1x, not 0.01. So this is like a 1, right? Invisible 1 there. So 1 minus 0.1 is 0.9 is equal to 90. Subtract 45 from both sides. So I get 0.9x is equal to 45. And divide both sides by 0.9 tells me that x, the amount of juice I need to add to that 900 gallons of soda, is equal to 50 gallons. So if I take 50 gallons of orange juice, dump it into this soda, I'll now have 950 gallons of soda, but the percentage of pure juice, a percentage of juice in that soda is now 10%, which means it satisfies the criteria. So that's it. An investment problem, a mixture problem. You can always use this table. It's just a matter of figuring out what information do I put into what box. Again, try the homework, see how many of them you can do. That way when you come to class, we can work the ones that gave you difficulties. And it's really a matter of getting that table set up, and once you have that, it generates the equations for you. So come on back, we'll look at video 2, which is going to be our work time problems.